All right, so today we're going to continue looking at section 3.1. So we're still going to look at some stuff with the inverse sine, cosine, and tangent. We're not really going to do inverse secant, cosecant, or cotangent today. All right, we're just going to stick with these three. So remember, we learned yesterday that if you do inverse sine and regular sine, it's kind of like if I said take the square root of 9 and then take that and square it. The square and the square root cancel each other out. And what you're left with is what you originally took the square root of, in this case 9. Well, same kind of thing happens here. If you take the sine of a value and then take the inverse sine of that, what basically happens is sine, inverse sine, cancel each other out. And what you're left with is what you originally took the sine of. Just like taking the square root of something and squaring it. They cancel each other out. Any question on that idea? Yeah?
Sorry, can you just repeat that?
So, let me just go back to this for a second. Oh, okay. So let's say we had the number 9, okay, and I want to take the square root of it. If I take the square root of 9, what do I get? 3. So if I take the square root of 9, I get 3. Now, what if I take that and square it? What do I get? 9. So I get back what I started with, because taking the square root of something and then squaring that cancels each other out. Right? Well, the same thing happens here. If you plug in a number for x like, let's say, 30. Let's take the sine of 30, and I wrote degrees right here, so I need to put in degrees. So let's take the sine of 30 degrees, and I get 0.5. Now, let's do the inverse sine of the sine of 30 degrees. So now it's going to take the sine of 30 degrees, it's going to get 0.5, but then it's going to take the inverse sine of 0.5, and you end up getting back the same answer that you started with, because inverse sine cancels out regular sine, just like squaring and square rooting. Now it worked here, right? Inverse sine of 30, 30 degrees. Let's do the inverse sine of the sine of 75. What should I get when I hit enter there? 75, because they cancel each other out. But watch what happens if I pick a number that's bigger than what we said we could use yesterday. Anybody remember when we did inverse sine, what the two angles had to be between? Negative this and positive this, Pete?
Was it 90 both ways?
Yeah. Negative 90 to 90. Well, let's try 120. We know that when you do inverse sine, it's never going to give you an answer bigger than 90. So if you plug in 120, you're not going to get the same thing back. So in order for inverse sine to cancel out regular sine, and you get back exactly the same thing you typed in, you had to have typed something in between negative 90 and positive 90. Or negative pi over 2 and positive pi over 2. And just like yesterday, it can equal negative 90 or 90. We saw with inverse tangent that it can't. So that's formula 2a. The name is not really important, that's just what your book called it. And this is formula 2b. What's the difference? If you look really quick, you might think they're just the same thing. There's a difference. Yes?
The regular side is on the outside.
Yeah, what we've done here is we've switched the regular sign and the inverse sign. You always do the one on the inside first, and then you do the one on the outside last. And that does make a difference. But under the right conditions, if you take the inverse sign of something and then take the sine, those two things will cancel each other out. I wouldn't write that in your notes because you need to read it. But those two things will cancel each other out, and you'll get back exactly the same thing you started with. As long as x is between -1 and +1. So let's try that. Let's try the sine of the inverse sine of 0.73. Okay. So I picked a number that is within -1 to 1. So what's going to happen, Ben, when I hit enter? What am I going to get? So what does that formula say we're going to get? If you plug in x, you would get back x. What did I plug in? I plugged in 0.73, so what am I going to get back? I'm going to get back 0.73. So I got back exactly the same thing I typed in, because they canceled out. Now let's try something that's not between -1 and 1. We saw what happened when we went outside the numbers we were supposed to. We got back something different than what we started with. This time, if we plug in something that's outside what we're supposed to, we don't even get back something different. We get an error saying you can't even do that. All right, so it doesn't work outside of -1 to 1. And that -1 to 1 has something to do with this. We looked at this picture yesterday. It's a graph of sine. And I'm going to put it on the board, make it a little bit bigger. What's the highest that it looks like that graph ever goes? Yep. 1. And Raymond, what does it look like the lowest it ever goes is?
-1.
Yeah, -1. It's always basically between those two lines, between -1 and 1. So the fact that that graph doesn't go any higher than 1 or lower than -1 has to do with why these are 1 and -1. Okay? There's a connection. All right, so let's look at the kind of problem I would give you with this. So this is one type of question you could have. It's a yes or a no answer. Is the inverse sine of the sine of pi over 8 equal to pi over 8? It's a question. Yes or no? So the first thing we want to figure out is what formula this is. It's either 2a or 2b. All right, so Colby, which formula is this one? All right, let's take a look. So 2a, inverse is on the outside. In our problem, inverse is on the outside. Yes. Okay, so now that we know it's 2a, this is what we're supposed to be between -pi over 2 and +pi over 2. Now, a lot of times if it's in degrees, people find it easier. Because it's easier to say, okay, am I between -90 and 90? Because it's not a fraction and it doesn't have pi. But let's see if you could convert this to degrees if you had to. But let's think about it on a number line. You're supposed to be between -pi over 2 and +pi over 2. So think about pi over 8. Lacey, where would pi over 8, or how would pi over 8 compare to pi over 2?
Wouldn't it be bigger? Or would it be smaller? I don't know.
Think about, pretend it wasn't pi. Pretend the number in the top was a 1.
Okay.
Just, it doesn't really matter, just
So
to
it'd be
compare.
closer to 0.
Yeah, 1/2 compared to 1/8. If you divide something by 8, it's closer to 0. So is pi over 8 between negative pi over 2 and pi over 2?
Yes.
Yes. It's like right in here. It's not 0, but it's, if you take pi and divide by 8, it is smaller than pi divided by 2. So the answer here is yes, that is what it's supposed to be between. So this would work. The answer there is yes. And the reason why? Because it's formula 2a, and you're supposed to be between these two numbers, and this number is. All right, let's try this one. Inverse sine of the sine of 3 pi over 2. So same setup, inverse is on the outside, just like the first one. This time the number we're plugging in is 3 pi over 2. So Cassidy, if we're supposed to be between negative pi over 2 and pi over 2, where would 3 pi over 2?
On the other side of pi over 2.
Yeah, it would be like to the left or the right?
The right.
To the right. This is pi over 2. This is triple pi over 2. So that's like way down here. It's 3 times bigger than pi over 2. That's way too big. That's not between negative pi over 2 and pi over 2. So the answer is no. That would not work. All right, let's look at this one. All right, Jaden, what formula does that one look like? 2a or 2b? So let's go up. So let's look at 2a, just to kind of remember what this one looks like. The inverse is on the inside. In formula 2a is the inverse on the inside.
Which one is the inverse?
The inverse, that's the one that has the negative 1.
No, it's not on the inside.
No, it's not on the inside, so it's not 2a. How about this one?
Yeah.
Yeah, in that one, the inverse is on the inside. So what does it say that x is supposed to be between? So let's scroll back down to our problem and see if we're between negative 1 and 1. Mateo, does that number that we're plugging in fit the condition it's supposed to?
Aren't you not supposed to have a number outside the point, like to the left?
Well, we've got to be between two numbers. What numbers did Jaden just say we had to be between?
You have to be between, it was negative 1 and 1.
Yeah, and is that number between negative 1 and 1?
No.
No. So this would not work. So the answer to that is no. Okay. Any question on that? All right, let's try one more. Same setup as the one above it. Inverse is on the inside. This time I'm plugging in 0.6. So Katrina, would that one work?
Yeah.
Yes. We're supposed to be between negative 1 and 1. 0.6 is definitely between those two numbers. So this one is yes. Okay. Any question on that? Now, one other way you could see a question like this worded is instead of a yes or no, you could say simplify, and I could do sine of the inverse sine of 0.6. If the directions say simplify, and you write yes, I'm going to write no. That's wrong. You can't write yes if it says simplify. What would I be looking for if it says simplify there? You don't even have to tell me an exact answer. Like if something says simplify or evaluate, what are they looking for? For an answer. Oh, Tom? So what if something like in math says evaluate? What does that mean they're looking for an answer? It might be a problem about degrees, but like if it just said, f of x equals 3x plus 7, evaluate when x equals 2. The kind of answer that they're looking for is a what? Yeah.
Like a finished number?
A number.
Simplest form.
Yeah, looking for a number. Okay, so when something says evaluate, or in this case, simplify, they're looking for a number for an answer. So if you write yes, that's not answering the question. Could anybody simplify that and tell me what we get? About 80? Yeah, I mean, it says it right here. We just answered the question, is the sine of the inverse sine of 0.6 equal to 0.6? We wrote, yes, it is. So now I'm asking you, what's the sine of the inverse sine of 0.6? We just said it was 0.6. So the answer here, what I'd be looking for is 0.6. Because remember, when you take the sine of the inverse sine, what happens to those two things? They cancel. When you take the sine of the inverse sine, it's like taking the square of the square root. They cancel each other out. And you're left with exactly what you started with, 0.6. All right, so we had two formulas for sine, 2a and 2b. We're going to have 2 for cosine and then 2 for tangent as well. Okay, so formula 4a looks kind of like formula 2a. So it's inverse cosine and cosine. Inverse is on the outside. What did we have to be between yesterday when we did inverse cosine? So inverse sine was the negative 90 to 90. Pete?
Negative 180 and 180.
I like the second number you said, the 180. But the first number is not negative 180. The second one is 180. Yeah, James? 0. Yeah, 0 to 180. So I'm not going to go through and show you on the calculator, but if you type a number in between 0 and 180, it works. If you type a number in that's not between 0 and 180, you'll get an answer back, but it won't be the one you started with. Again, when we switch it, so the inverse is on the inside, we have those two things will cancel out, but we do have a restriction. Let's look at the graph of cosine. So remember, when we figured this out last time, it had to do with how high and low the graph of sine went. Well, look at the graph of cosine. How high and low does it look like the graph of cosine goes? About Ben? So it's the same as sine. The only difference between sine and cosine is the red one is kind of maybe moved to the left a little bit, but it's exactly the same high and low point as the blue one. So what did we say earlier was the highest the blue one went and the lowest? 1 was the highest and -1. So the condition here is exactly the same as the condition for formula 2b. I'm not going to go through as many, but let's just try a couple. So Raymond, the cosine of the inverse cosine of 0.95, is that equal to 0.95? What formula are we looking at here? 4a or 4b?
Can I see the problem here?
Yep.
4B.
Yep. 4b. The inverse is on the inside. Inverse is on the inside. So Colby, what are we supposed to be between in formula 4b? Colby, yep.
-1 and 1.
Yep, -1 to 1. And in this case, Lacey, what did I plug in?
0.95.
And is 0.95 between -1 and 1?
Yes.
So the answer here is yes. We figured out the formula and what we had to be between, and that number is between. So, perfect. All right, let's look at this one. The inverse cosine of the cosine of 210 degrees. All right. So Jacob, which formula does that one look like?
4a.
Yep. Inverse is on the outside. Inverse is on the outside. What are we supposed to be between, Jacob, for formula 4a?
0 and 180.
0 and 180. All right, so Cassidy, what number did I plug in?
210.
Is that between 0 and 180? No. So that doesn't work. Okay, any questions on that one? All right, and lastly, inverse tangent. So inverse tangent of regular tangent, remember this is not multiplication. Okay? This doesn't mean like inverse tangent times tangent. If I wanted to maybe show it, it just means take the tangent of x and then take that number and plug it into the inverse tangent. So there is no multiplication, addition, subtraction, or division in this whole problem. All right, how about, Jess, what did we have yesterday when we did inverse tangent as the numbers we had to be between?
-90 and 90.
And can we equal them?
No.
No. So that's why here, it says you've got to be between -90 and 90, but this time it's not equal to. And for this one, okay, I didn't show you guys the graph of this one, but the B version of every formula has always been how high and low the graph goes. We haven't really looked at that tangent, but I'll graph it and show it to you. How high and low do you think that graph goes? What is it? It does. It goes infinitely high and low. It goes up and down forever. Which means on this one, there really is no restriction. You can have a number as big as you want or as small as you want, and formula 6b always works. Now that's not a graph that we study in this class, the tangent one. Okay, we only study the sine and the cosine. But every now and then it helps me to just kind of put it up there because if there's kind of something simple I can show you about it, it connects with this. All right. So Jaden, is the tangent of the inverse tangent of 30.4 going to come out to 30.4.
Yeah.
Okay, how come?
It's gonna be negative.
So start by identifying which formula is it, 6a or 6b?
Can I see them again?
Yep.
Six.
It is 6b. And what's the restriction on the number you can plug in for x in formula 6b?
Infinity.
As high as infinity and as low as, which really means what?
Any number.
Any number. Okay, so is 30.4 any number? Sure is, yep. You can plug in any number you want. So this answer here is yes. Right, and that's the end of 3.1. Okay, the first part of what we're doing. Any questions on that? Yes,
Can you just go back up to the cosine ones?
the cosine ones, yep.
Just the formula.
All right, so now we'll take a look at the first part of 4.1. We're not going to finish it today. We'll do a little bit, and then we'll finish it up tomorrow. So 4.1 talks about what we call right triangle trigonometry. We did unit circle trigonometry a couple weeks ago. This is basically another way of doing the same kind of thing, except we're not going to do anything with a circle this week. We're going to do things with right triangles. So first, can someone just describe to me what is a right triangle? What does that mean? Pete?
Triangle with a right angle in it.
Okay, it has a right angle. What's a right angle?
90 degrees.
90 degrees. What do we call the side that's across from a 90-degree angle? It's the longest side. James? Hypotenuse. And what do we call the two shorter sides that are not the hypotenuse? Yep,
The legs.
the legs. Right? So there's a diagram of everything that both of you guys just said. Triangle with a 90-degree angle. Hypotenuse is the longest side. The two shorter sides are the legs. Any questions on that? Okay. Inside a right triangle, these two angles are what we call acute angles. Does anyone remember what does that mean? If an angle is acute, Ava?
Less than 90 degrees.
Yep, it's less than 90, and it also has to be more than what? Because we've talked about certain kind of angles in this class that are less than 90, but they would not be acute. I think it has to be more than. Yep. It does have to be more than 0. Okay, we've talked about like a negative 20-degree angle going the other way on a unit circle. Negative 20 is not acute. Okay. It's got to be less than 90, but also greater than 0. And it can't be 0 because if your angle was 0, then you wouldn't have an angle. All right, so Pythagorean Theorem. Could someone explain to me? Well, let's first just write down that theorem. How do people normally write that theorem down? Yeah. Pete? Yeah.
Oh, A squared plus B squared is C squared.
Okay, a squared plus b squared equals c squared. Now, can somebody explain to me what does all that mean? What's a squared plus b squared plus c squared? I'm not sure what that means. Yeah.
The length of the two legs squared equals the length of the hypotenuse squared.
Yeah, the length of the two legs squared and then added together equals the length of the hypotenuse squared. So the Pythagorean theorem is a formula that involves the sides of a triangle. It has nothing to do with the angles of a triangle. Just the sides. If you're trying to figure out what an angle is in a triangle, this is not the formula to use. It's not going to help. So we're going to talk about how to define the 6 trig functions on the next page. But first, there's a couple words that are going to come up in the definitions that I need to make sure that we understand. Hypotenuse is one of them. And that one's pretty easy. That's just the side that's opposite the right angle. The other 2 words that are going to come up are opposite and adjacent. And opposite and adjacent are kind of like the terms left and right. I couldn't put a sign on the wall in this room that says this is the left wall, because left is relative to you. Depends which way you're facing. Right? For me, left is the door. For you, left is the windows. So left and right are from the perspective of the person you're talking about the left and right from. That's how opposite and adjacent are. They are from the perspective of one of the angles in the triangle. Which angle? They'll always mark the angle that they want you to have as your perspective. In this case, they mark the angle in the lower right. That means if I was standing right here and looking out at my triangle, not looking in towards the corner, but like looking out, this is the side that would be opposite, because it is farthest away from the angle. It's not connected to that angle in any way. I could erase this side, and it has no effect on that angle at all. That angle is still right there. Adjacent is the side that's next to the angle. And you might say, well, there's 2 sides next to the angle. Yes, but this one already has an angle. It's across from the 90, so it's the hypotenuse. Adjacent is the side that if you had a triangle, let's say like this, and there's your angle. If you took out the adjacent side, you don't have an angle there anymore. You have an open side on the bottom. So adjacent is the side that is part of the angle. And that's what I have written right here. So opposite is the side in a triangle that's not part of the angle being referenced at all. You can erase the opposite side and it has no effect on your angle. Just like this. That angle is still right there, and no effect on it. But the adjacent is the side in the triangle that does make up one of the sides of the angle we're talking about. If you erase that adjacent side, you don't have an angle anymore. And remember, there are 2 sides that are always next to the angle, but one of them is already labeled the hypotenuse. Okay, so I call opposite and adjacent relative terms. They're relative to the angle you're talking about. Just like left and right are relative to you and me. Depends which way we're facing. So let's say we had the same triangle, but I mark theta up here. Well, that's facing a different way now. Now opposite is the bottom, and adjacent is the height. Okay, so any questions on those two words, opposite and adjacent? Okay, so now let's write the definitions of the 6 trig functions, but this week we're not using a coordinate. Last week you had to know an x and a y value. We don't need that this week. So sine is defined to be the length of the opposite side divided by the length of the hypotenuse. Cosine is the length of the adjacent side over the length of the hypotenuse. And tangent is the length of the opposite over the length of the adjacent. So think about what the units would be on this. You're dividing two numbers that are lengths. Let's just make up two lengths. 8 centimeters divided by 11 centimeters. Let's say 8 was your adjacent and 11 was your hypotenuse. When we divide these two numbers, what cancels out? Yep.
Centimeters.
Centimeters. So all you're left with is a pure number that has no label. Right, so just to be clear on that, when you do the sine, cosine, or the tangent, regular, not inverse, that's different. When you do regular sine, cosine, or tangent, the result is a number without a label, just a number. The label cancels out. All right, now, what did we do once we had the 3 on the left to get the 3 on the right? Yep, we flip them, and that's exactly the same thing this week. So your cosecant is hypotenuse over opposite. Your secant is hypotenuse over adjacent. And your cotangent is adjacent over opposite. And there's different ways or tricks that people use to try to remember. One of the tricks is this. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Anybody ever seen that before? Sakatoa? Yeah. One year I asked, how can we remember the different trig functions? And somebody said Sacagawea. Well, maybe she could help. I don't think so, but Sakatoa, that'll help. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And if you remember those 3, the other 3 are just split. So let's try an example where we have to find all 6 of those trig functions. So it says find the 6 trig functions of theta. Now, out of the 6, there's 2 of them we could do right now. But think about what am I missing to be able to do the other 4? All right, so what am I missing here that I should probably find first? Because I'm going to need this to do 4 out of these 6 trig functions. Eva? Yeah, I'm missing the hypotenuse. And how can we find the hypotenuse? What formula helps us do that? Yeah, James? What is it? Yeah, the Pythagorean Theorem. So this one, 3 squared plus 4 squared equals c squared. So when I do that out, I get 25 equals c squared. which means in this case, Olivia, what's my hypotenuse going to come out to?
I don't know, like C over 25, or like
So how do you get rid of this exponent of 2?
divide by 2.
That's if you had the 2 in front, like that.
Square? Wait, no.
So that's squared. We have
No,
to undo
the
square.
square root?
Yeah, we gotta do the square root. Good. So square and square root cancel, and what are you left with on the other side?
25. No.
Careful. 5. Right? Square root of 25 gives me 5. Now that's nice that we got a good an answer without a square root there, because if that number, let's say it was the square root of like 26, well, we would have had to just leave it like that, and then you might be dealing with square roots in the bottom of a fraction. Okay? This time we don't have any square roots, so we don't have to worry about fractions that have square roots in the bottom. All right, so Raymond, what's my sine going to be using this triangle?
Would be 4 over 5.
Yeah, sine is opposite over hypotenuse. My opposite is 4. My hypotenuse is 5. And if you're wondering again, well, what units should I put on that? There is no unit. It's a length divided by a length. Whatever the length unit is, it would have canceled out. I didn't even write the length units, but you don't need them. All right, Ben, what about my cosine? So we need the formula from cosine from the previous page. Anyone help that out? What's our formula for? I gave you guys that trick, that Sakatoa. Maybe it's helpful. I don't know. Yep.
3 over 5.
Yeah. Cosine is adjacent over hypotenuse, which in this case is 3 over 5. And how about my tangent? Cassidy, what's my tangent going to be?
4 over 3.
Opposite over adjacent, 4 over 3. And as someone maybe just said earlier, to get the other 3, we just take those and flip them. No square roots means we don't have to worry about anything ending up in the bottom. That's a square root. So 5/3 and 3/4. Now, just to be clear, you did not solve for theta. We don't know how big this angle is. That's not the goal of what we were trying to do here. We were describing the sine of theta, the cosine of theta. Tomorrow, we'll actually find theta. In any one of these 6 pieces of information, I could get theta by itself and find it. These first 2 would probably be the easiest. Any questions on that? Okay. Complementary angles. Anybody remember what that means from geometry? Complementary angles are
Add
called?
up to 90.
That's supplementary, but you usually study those at the same time, so it's easy to mix them up. Yep.
So only equal 90.
They add up to 90.
Yeah.
So they don't, yeah, they might equal 40 and 50, or 30 and 60, or 10 and 80, but they add up together to be 90. Now the next thing I'm saying here is that the 2 acute angles in a right triangle are always complementary. Let's call them 1 and 2. Why is 1 plus 2 always going to be complementary? Ben?
Does they add here?
Well, yes, that's what I'm saying. I'm saying 1 and 2 will always add together to make 90, but why? Anybody answer that? Why will 1 and 2 always add together to be 90?
Because all three angles, or they all add up to 180.
All 3 angles add up to 180. Okay. Still doesn't tell me why angles 1 and 2 have to add up to 90. Pete?
In any order you, well, no, because that's just the way it has to, that's how it works.
How come? Why?
I don't
I
know.
need someone to articulate this for me. Prove it to me. Why? Yeah. James?
Because all the angles in a triangle have to equal 180, and it's a right triangle, so it's a little wow. There's already an angle that's 90 degrees.
So we already have, all the angles have to add up to 180. That's an important piece. And you've already used 90 right there. Well, if you've already used up 90, and they all have to add up to 180, then these other 2 angles together have to add up to 90 to make everything add up to 180. Okay? So those 2 angles are always going to be complementary. So, we're going to combine that. This might seem totally separate, but these 2 things, complementary and cofunctions, are going to connect. Cofunctions are just another way to pair up the 6 trig functions. Usually, we pair them up this way. Sine with cosecant, cosine with secant, tangent with cotangent. When you pair them that way, the connection is you flip one to get the other. Fancy word is reciprocal. This pairing is called cofunctions. And basically all that a cofunction is when you take a function and put the word co in front of it. That's its cofunction. So you have sine, put the word co in front of it, cosine. Secant, put the word co in front of it, cosecant. And then tangent, put the word co in front of it, cotangent. These are also paired when we do it the other way as well. These are the only 2 that are paired both ways. You flip one to get the other, and their names are cofunctions. So let's take a look at this, and let's find the sine. Bless you. Actually, let's do. Oh, that's fine. We can do that. Let's do the sine of alpha. Now, it's not a number here. It's just going to be 2 letters. But can anybody tell me what the sine of alpha would be? So remember, this is your perspective. Think of the definition of sine, and then look at what's in the 2 letters that are in the spots for the definition you're going to use. Yeah, Jacob?
A over C.
Opposite over hypotenuse is A over C. Now, what function is paired with sine when you do cofunctions? James? The cosine. Okay, so let's try that. Cosine. And what angle is complementary to alpha in that triangle? Okay? Beta. So we just did 2 things. I asked for the cofunction, and I asked for the angle that was complementary. Cofunction, complementary. Let's see what this comes out to. Cosine is adjacent over hypotenuse. That's your perspective. Aiden, what side is adjacent to beta?
A,
A, and what's the hypotenuse?
C.
C. A over C. A over C, A over C. They came out exactly the same. And we did two things. Sine and cosine are cofunctions. Alpha and beta are complementary. That will always happen. If these two are cofunctions and these two are complementary, the answer always comes out exactly the same. And that's called the complementary angle theorem. Cofunctions of angles that are complementary come out the same. They come out equal. So what I've written down is 3 trig functions on the left with numbers. This time we're not going to use letters. And I want to know what that would be equal to on the right using this idea right here. So what I'm looking for that's under this gray box, you have to make 2 changes. 1, find the cofunction of what I just underlined. And 2, find the complement to that angle. Remember, complement means it makes it add up to 90. So what's the trig function that's the cofunction of sine? Ava?
Cosine?
Cosine. And what angle is complementary to 30? Yep, just
60.
60. Those 2 things would come out exactly the same. I'm not going to type it in, but you could try it if you don't believe me. They come out exactly the same. Let's look at this one. What's the cofunction for tangent? Ava?
Cotangent?
Cotangent. And what angle is complementary to 15? Then 75. Tangent of 15, and cotangent of 75 come out exactly the same. Try one more. Secant of 40. Anyone think they can tell me what that would be the same as? Yeah. Of? Yeah.
50?
50. Secant, cosecant, those are cofunctions. 40 and 50 are complementary. So we're just finding things that are equal. You might be like, well, what good is that? What does that do?
Just do 90.
So look at this one. They want to know what the sine of 15 is divided by the cosine of 75. Directions here might say simplify. Now, off the top of my head, I don't know what the sine of 15 is. That's not an easy one to remember. I also don't know the cosine of 75. But to do this problem, you don't need to know what the top is and what the bottom is. If you're trying to think of it that way, that's more work than you need to do. Anyone think they know what this comes out to? Yep.
1 over 1, so just 1.
It comes out to 1. Sine and cosine are cofunctions. 15 and 75 are complementary. I'm dividing cofunctions of complementary angles. They are equal. So I don't know what the top is and I don't know what the bottom is, but I know I'm dividing 2 things that are the same. And I do know when you divide 2 things that are the same, the answer is always 1. Now they could change it, like if they put a negative in like that, now the answer would be -1. But, I mean, there's not really much variation on this kind of thing. All right, how about this one? The tangent of 12 minus the cotangent of 78. Again, this time I have no idea what the tangent of 12 is, nor do I know what the cotangent of 78 is. But I don't need to know them to do this problem. How does the tangent of 12 compare to the cotangent of 78. That's what's important. Yes?
They're the same, so it would just be 0.
Yeah, they're the same. Tangent, cotangent, 12 and 78 add up to 90. If I change this to a 79, that messes up the whole problem. You can't do it without a calculator. Tangent of 12 minus cotangent of 78. When I subtract two things that are the same, I get 0. How about if I did this with addition? If I add two things that are the same, do I always get the same answer? What happens when you add two things that are the same? What happens to your number? Yep, James? It doubles. So what does it mean to double something? Well, it depends what you started with. Every answer could be different. So it works with subtraction. It works with division. How about multiplication? If I multiply two things that are the same, do I get the same answer? No. What do I get?
Squared.
I get that answer squared. What does that mean? Depends what I started with. So this trick wouldn't really help you with multiplication or addition, but it does work with division and subtraction. Any questions about that? All right, so that's the end of 3.1 and the first part of 4.1. So page 187, those are all the yes-no type of questions we did at the beginning. And on 255, those are finding like the sine, cosine, the tangent, things like that.